It is important to notice that a plus b squared is not equal to a squared plus b squared. Let's do an example of this by picking specific values for a and b, and we can see that this equality does not hold. So if we pick a equal to 3 and b equal to 4, then 3 plus 4 squared would be 7 squared, which is equal to 49. And 3 squared plus 4 squared would be 9 plus 16, which is 25. And since 49 is not equal to 25, then we can see that 3 plus 4 squared is not equal to 3 squared plus 4 squared. In other words, you have to fight the urge to what some students would call distribute this exponent to the inside terms. Right? That doesn't hold for exponents, and we can see why. We have an example right here. But we would like to know what a plus b squared is equal to, so let's find out. So whenever we see something squared, that really means that thing times itself. And we know how to solve something like this, right? We can just FOIL this, and we would get a squared plus ab plus ab plus b squared, which simplifies to a squared plus 2ab plus b squared. So we've now found another one of those forms that commonly pops up, and if we recognize the form early on, in other words, we recognize that we're dealing with a square, then we can go right to the end and know exactly what the form's going to look like. If we forget the formula or we don't recognize it early on in the beginning, we can always just multiply everything out and get our answer that way. So if we want to know what 2x plus 5y squared is equal to, well, you can either use the formula that we just figured out, or you can FOIL them. For our first terms, we'd get 2x times 2x, so we'd get 4x squared. For our outer terms, we'd get 2x times 5y, or 10xy. For the inner terms, we get the same thing, 2x times 5y, or plus 10xy. And for our last terms, we get 5y times 5y is plus 25y squared. Simplifying this whole thing, we get 4x squared plus 20xy plus 25y squared, which is exactly what our formula predicted.